Oh yeah, let's talk about confidential computing. How many people have heard of confidential computing? So quite a few of you have. Word's getting out. It's been a huge year for confidential computing, which promises to protect data while it's in use, which accompanies data protection at rest and data protection in transit. And it does this with a hardware-rooted trust, which creates a box. Unlike hypervisor isolation I was just talking about, this creates a shell around an application. That shell is encrypted and rooted in hardware that measures what's in that box and signs it so that that box can present itself to something else, which will then know that it's being protected by hardware, AMD SEV, SMP, or Intel TDX, which is coming out, confidential virtual machine technology. It's also been a great year in terms of GPUs. So we've been partnering with NVIDIA to bring out confidential GPUs. Version of a confidential GPU in A100s and full confidentiality in the H100 Hopper GPUs, which preview is coming soon for. This will allow end-to-end protection of AI workloads, whether training or inference, between the GPU and the CPU. We've also been working on bringing confidentiality to pods, and we announced confidential ACI earlier this spring. We're showing you a preview of what we're working on with the Kata open source community, not just on Kata strong isolation, but also Kata confidentiality. So this is called Kata CC for confidential containers. And the idea here is that you can make a shell around a container running on Kubernetes and making that confidential. And I want to show you an example of that with the scenario, which is we're in a store, we're seeing cell phone signals of customers coming into the store. And for customers that have registered with us, we want to send them coupons as they shop around the store. But we want to protect the confidentiality of people that aren't our customers that are coming into the store and make sure that nobody sees those cell phone records. So the way to do that is to have the processing of those queries sitting in confidential computing. So here, the cell phone reader, the producer here, is going to be sending encrypted cell phone IDs to event hubs through Dapper, which will then be read by the application, which will decrypt them because they're running in confidential computing and be able to send coupons. And so let's go take a look at that in action. So here I'm running the Dapper producer. It's creating these encrypted fake cell phone messages. IMEIs are the way you identify cell phones. If we go look at event hubs, you can see that we've got a bunch of messages with encrypted cell phone IDs queued up, because we haven't launched the consumer yet, which we're going to do now. And so you can see the consumer code is going to decrypt the message it gets, because it gets a decryption key based on the fact that it's running in confidential computing, check in a database, and just print out to the log whether there was a match or not. In real life, this would actually kick off the coupon code that I mentioned. Here's the deployment YAML. There's the Dapper annotations to talk to the pub sub. Here's the code that says where it should get the decryption key from if it presents evidence that it's running in confidential computing. And there's the Kata CC isolation at request when it launches. And so here I'm going to launch the pod. And at that point, it's going to start consuming the logs. So let's go dump logs. And you can see the logs that it's dumping. Well, first it tells us it's running in SNP confidentially. And then it's going to show here, dump the encrypted IDs that it sees. This isn't going to give us any information about who's in the store, but it then tells us it didn't match our database, and so listening for more. And this one happens to be a customer that's registered in the database. We have a match, and this is where we would kick off the code to go send them a coupon. And again, nobody has access to those cell phone records of who's coming into the store.